folks, welcome back to another video. Today we're looking at question 678, valid parenthesis string. The way we'll be approaching the problem is by keeping two variables. Basically, these two variables will keep a track of the number of maximum number of left characters that need to be closed, and the left characters in this case is like the opening parenthesis. And why do we have a min and a max? The reason why we have a min and a max is because the star right here adds multiple complexities to the question, meaning when there's a star, it can be, we can count that either as like an opening parenthesis or a closing parenthesis. So that will add to whether we have something to close or we just keep it as is, or we use that as an opening parenthesis. So that's the reason why we need two variables. It becomes a little easier as we go through the question, so let's get started. Let's initialize two variables, left max. This would be equal to 0. Int left min. So this will be the minimum number of left parentheses. So actual left parentheses that have to be closed, and left max would be including the stars that we're counting. So these two values will keep a track of the number of possibilities that can happen, right? So once you have those two set up, you need to iterate through all of the characters in the string. So you convert that to a char array, go through all of the characters. Right. So if it is an opening bracket, right? So we know this has to be matched. So you increase left max by 1 and you increase left min by 1 as well, because they have to be matched and it has to be closed. So if character is equal to a closing bracket, and this is defined, so this is closing something, right? So you decrement left max by 1 and left min you also decrement as 1. Yes. And if the last case that you have to deal with is if the character is equal to a star, which is basically a wild character that can open, it can act as an opening bracket or as a closing bracket. So if we are looking at it as an opening bracket, so left max has to increase, basically meaning that we have one more left bracket to close. And if you're seeing it as closing bracket, we need to subtract the number of left brackets that we have to reduce. So basically we are using it as a closing bracket, so we don't have to worry about one left character. So we decrease the left minimum by 1, right? So after all these are done, these are the possible values that left max and left min can adopt. So left max can be positive, negative, or 0. So let's think about what's valid in our case, right? So what makes a string valid? So if the left max is positive, what exactly does that mean? That means like we have more opening parentheses, which can be possibly closed later, right? Which is fine. But if left max is negative, it's basically implying that there are more closing brackets than opening brackets. So if that is the case, it is invalid. So you return it as false. So basically, this is a case where we hit more closing brackets than opening brackets, and the only time you're decreasing max left is in this case, right? So if it is negative, that basically means that we have hit more closing than opening. So that case is invalid. So as soon as it hits less than 0, you return it as false, right? And if left max is equal to 0, what exactly does that mean? It means that everything that we've seen so far matches as is, and it's fine, right? So we've handled these three cases, and it makes sense. So what about the cases in left min, right? Let's examine that. So in left min, if it is positive, as in, okay, there are more there are more opening brackets that need to be closed, and that's fine, right? So like we continue through the string, and there might be more closing brackets that can be matched, and that's fine. So what does negative left minimum mean? Left minimum doesn't necessarily exist, as in their minimum number of opening brackets that needs to be closed. That doesn't make sense. So we need to reset that. And why does it make sense for us to reset that? I'll tell you in a second. So left min, you reset that to math.max of either 0 or left min. And where are we reducing this? We're reducing left min in two cases. We're reducing it here. In this case, it's fine. And if left min right, yeah. So if left min is negative, the left min, we're subtracting it in two cases. We're subtracting it here and subtracting it here. So if left min falls to negative, which basically means that there are more closing brackets than opening brackets, it's already been taken care of by this case. So we're taking it as, okay, there are more closing brackets than opening brackets, so we return 0, right? But the only other case that's left is here. So left minimum, as in like we're taking this as a closing bracket, but we don't have to consider it as a closing bracket, right? So it could be like an extra character or things like that. That's the reason why we reset this to 0, because that case is not valid at all. The negative number of left brackets that need to be closed, right? So those are resetting of cases, and you're basically checking left min and left max in all of the possible realm, right? Positive, negative, and 0. And in the end, you just need to make sure that the minimum number has been matched. So it's set to 0, and only if it's equal to 0, we know it's a valid string, otherwise it's false. Let's try compiling this. Okay, so the first few test cases are okay. Everything else is okay as well. Awesome. Let's talk about the space and time complexity of this problem. The time complexity of the entire solution is of n. Since we are iterating through all of the characters in the string, the space complexity is of 1. Since we're not using any additional space, we're just using two constants to keep a track of it. Awesome. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I'd really appreciate that. Keeps me motivated to make more videos. Thanks so much, and I'll see you